Hello students, welcome back to my channel once again. This video I am going to explain about the chemical reactions of amides. Okay, so previous video you have seen I have explained reactions of anhydrides and also reactions of acid chlorides. These are all under derivatives of carboxylic acid. Students, we have all these three in your syllabus, students. Okay, so please kindly put the side heading reactions of amides. So this video I am going to explain a very important reaction, students, which is called as a named reaction. It is the Hofmann degradation, which comes under reactions of amides. Okay, so before Hofmann degradation there are two simple reactions. So put number 1, CH3CO and H2. Students, you know amide. What is amide? What is the general formula of amide, students? RC double bond O and H2. RCO and H2. Okay. So this portion, this group is called as amide. So we are taking here the example CH3CO and H2. This is acetamide plus HO and O nitrous acid HNO2. Okay. What is happening? The products that we are getting CH3COOH plus N2 plus H2O. CH3CO and H2 plus HONO gives acetic acid plus N2 plus H2O. So how did this happen, students? So this bond is broken. CH3 C double bond O, OH from HONO, this is HNO2. Next, this nitrogen, N2, and this H2 and one oxygen from nitrous acid will be coming out as water molecule. This is reaction with nitrous acid. Next, second one, amide R C double bond O and H2 on reduction, that is on addition of 4 hydrogens. What are we getting, students? Now tell me, what is the functional group present in this compound, students? RCH2NH2. This is amide. Okay, C double bond O and H2 is amide. Now the product that we are getting, there is no C double bond O here. There is only NH2. So this is amine. This is amide. AMIDE. This is AMINE, students, plus H2O. Okay. So are you thinking how RCONH2 is converted into RCH2NH2, students? CH2O is removed here. So 2 hydrogens, 1 oxygen, H2O is removed and 2 hydrogens will be joining this carbon, by which we are getting here CH2, RCH2NH2. Okay, this is amide, students, this is amine. Next, coming to the important reaction under amides, that is Hofmann degradation, students. We have the mechanism of this reaction also. So look at the reaction. Taking acetamide, CH3C double bond O NH2 plus Br2 in the presence of NaOH, we are getting CH3NH2 plus H2CO3. So CH3CONH2 is converted into CH3NH2, students. So what happened here? Look at the name. The name is degradation. Here, how many carbons are there? 2 carbons. The product that we are getting only 1 carbon. So degradation. Okay, there is a reduction in the number of carbons. Hence it is called as degradation. Hofmann degradation. Acetamide being converted into methylamine and in the presence of NaOH on bromination. So put the side heading mechanism, students. Okay. So we will see how 1 carbon is being reduced. Okay. So I have taken here RC double bond O NH2 on bromination. What happens? This H and Br will be coming out as HBr. Okay, students. Next, so in the place of this hydrogen, this Br will be replaced. So next we will get RC double bond O, N, here Br and here H. Okay. So as we have seen, the reaction is taking place in the presence of NaOH. Now here write down, put an arrow and here write down OH minus. Okay. In the presence of this OH minus, what is happening? So this OH minus abstracts this H as H plus and this bond will be shifted to nitrogen. Okay, you can write here, students. Okay, OH minus will be taking up this hydrogen and this bond will be shifted to nitrogen. Fine. So what happens when this bond is shifted to nitrogen? It gets a negative charge and this H will be going out as H2O. Okay. So minus H2. Fine. Next. RC double bond O. Now look here, students, I have mentioned here negative charge because this bond is shifted to nitrogen. So N minus and this Br I have written here. Okay. So next some rearrangement takes place here. What is happening in this rearrangement, students? This Br will be coming out as Br minus as I have shown here. So why this Br minus is coming out here? Because this R with these 2 electrons will be shifting to, I will show you, students. So it comes near this nitrogen. That means now this R is not on this carbon. It will be on nitrogen. So that's the reason. See how I am drawing the, I am showing the representation of this arrow, students. Okay. So R with this bond coming to this nitrogen and hence this Br along with the 2 electrons is going out as Br minus. Okay, the way we show the arrows should give us the complete meaning, students. Br with the 2 electrons coming out as Br minus, R with these 2 electrons coming to nitrogen. Here while showing H, how did I show? I did not touch this bond. Okay. So while showing you the arrow, H is coming out as H plus. That's the reason I have mentioned the arrow beside this line, students, beside the bond. Try to understand. Okay. Then if you write like this in your exam or if you write like this in your notebook, it will be very easy to understand also and also to practice. Okay. So after this rearrangement, next what is happening? I will show you. Look here, students. R is now on nitrogen. This minus is like that only. C double bond O. Now, from this carbon, R is shifted to nitrogen, right? Along with the 2 electrons. Now, C has no 4th bond and hence it is acquiring positive charge. So, kindly mention positive charge on this carbon. Why? Because R from C shifted to nitrogen. Written, students, minus on nitrogen and plus on carbon. Next, what is happening, students? Next, we are getting R N double bond C double bond O. Can you guess how this has happened? From here, we are getting this one, students. Can you just imagine or can you just guess what might have happened? Yes, exactly. So this minus negative charge on nitrogen will be shifted between nitrogen and carbon. This is the reason here we are getting R and double bond C double bond O. Next, on hydrolysis, put an arrow and write H2O, students. On hydrolysis, we are getting RNH2. Can you see? Yes, RNH2 plus H2O plus CO2 or H2CO3. Okay, so how we are getting RNH2? This bond and this bond will be broken. HOH students. So total whatever is remaining here, we can write it as H2CO3, or you can write separately as H2O plus CO2 students. So this is all about the mechanism of Hofmann degradation. Please kindly practice it twice or thrice, and this is under the chemical reactions or properties of amides students. Okay, so whoever is watching for the first time, subscribe the channel, like the video and share it with your friends students. So with this we completed derivatives of carboxylic acids. Thank you all students. Meet you in the next video with a new topic. Take care.